So, I've been working on something called stateful objects, and well, I'm just going to show you straight away what that means. So a stateful object is an object that can have a number of states, excluding things like characters. Oh, don't know what happened there. Physics 3 is a bit funny. Let me just turn that music down. Okay, so for example, this gate is a stateful object. It can have a number of states, for example, unlocked. So you can see this door here is in an unlocked state, and it can have a locked state. It could have a broken state, it could have an erratic state, sort of like Dead Space where it just goes crazy. Now, that's one part of it. You know, you can easily have an object that has a bunch of states, but what's really important is having relationships between different stateful objects. So, if you come have a look over here, we have a little console switch thing. I haven't coded the code to get my character to actually switch it, but I've hard-coded it to keys for now. So, I'm just going to turn on as well the trigger debugging, so you can see the triggers. So, just a quick recap, when it's red, it's not being triggered, green is being triggered, and if you have a look at these ones, these doors over here, if it's blue, it means it's inactive. It won't register any triggers. So, now I'm just going to press the key 2. Now, I've hard-coded the key 2 to the switch, not to the gate. I've hard-coded it to the switch to turn the switch to a state of off. The switch is also a stateful object. It has a state of on and it has a state of off. So when I switch it to a state of off, you'll see now the gate was affected. It deactivated its trigger and it's locked. So how did I get this relationship going? I can tell you now it's not hard-coded. You can hard-code these things, but this is not hard-coded at all. I'll show you this in the editor in a sec. These, as you can see, like it's definitely not hard-coded because these gates up here, they didn't change at all when I did that, and they don't have switches attached to them. So let's go have a look at how that's done in the editor. Alright, so here we are in the editor, and we're going to have a look at our level, just to show you the different bits and pieces there. You can see here that these are different objects. This is a gate, and I've got a bunch of stats. And you can see here, this is the gate state. It has to start in a state, and I've chosen it to start in state open. And these are enumerations because my states are identified by integers as enumerators. So state is gate open. So that's a single object by itself. And here is a switch. And our switch, you can see it's got all these extra parameters here. Though if you look at the actual object for a switch that I've made, it only has these two. So these two at the top, the name of the switch and the starting state. Now the name of this gate is also very important. Basically any stateful object only 100% requires a name, which he's got here, it's gate 01, and a starting state. So now, what are all these extra things here? Well, this is my way of linking the two together. I mean, in a lot of engines, I guess, they sort of force a certain way of doing this on you. Maybe they have flow graph editor, whatever, and they usually require scripting to do that, and I don't like scripting, so this is my solution. These extra parameters basically set up the two relationships between this switch and this gate, and that is relationship 1, when this switch goes to its on state, it makes this gate go to its open state. Relationship 2 is when this switch goes to its off state, this gate goes to its lock state. So let's have a look at these states. So you can see they're named 1, 2, 1, 2, 1, 2. So 1 is relationship 1, so they're all together. All the 1s are together and all the 2s are together. Now, if you look, so SF rel underscore name. So SF stands for stateful, rel stands for relationship. So this is saying, okay, gate 01, that's the name of this gate. I'm in the switch parameters now. It's saying relationship 1 is with gate 01. That's the name of that stateful object. Okay, and now we have sfrel on underscore 1. So this means in stateful relationship 1, this is the state that triggers this relationship to happen. So this is like saying this switch will affect gate 01 when it goes into its on state. Alright, now the last part is sfrel 2. So this means, alright, so when the switch goes into its on state, it will make the gate go into its to state. And you can see here I've linked that up. So gate 01, when the switch is in its on state, goes into the gate open state. And you can see gate number 2, it's also a same relationship with gate 01, and it will cause it to go, when it goes into its switch off state, it causes the gate to go to its gate locked state. So every stateful object has to have its own enumeration to do this. Or, I mean, I could make it integers, but it's much more easy to read and understand because it can even get a bit complicated like this and a bit silly, but this is the best way I've been able to find how to do it. So, now, let's give that a try. I'm going to now, what I'm going to do, this switch is of course hard-coded. I'll show you for turning it on and off at the moment. It won't be later on. And what I'm going to do is I'm going to link this switch to the second gate here, except it's going to be a bit different. I'm going to need its gate. Its name is gate 03. It's going to be a bit different. I want this switch to turn this gate this gate open, and then at the same time locked. So I want the gates to be alternating. So let's have a look. Let's add a new parameter, and we'll make it a string. So in this system, I can make as many relationships as I want, because it'll automatically detect where they are, as long as they're sequential, so 1, 2, 3, etc., with the same beginning parts. So gate 03, relationship with gate 03, and we want so the switch states when it goes on, so tsfrel on 3, yes, and we want the gate then to go to, hang on, so what did we do? On for 1 was open, so we'll make it the opposite, so locked. tsfrel underscore 2, 3. And then of course we've got to do the opposite, just bear with me. Still getting used to the names that I've done. Name 4, gate 03. You're usually not going to have too many relationships, but you know, like you're not going to have infinity relationships between these things, but it's good that I'm happy that it has the capability of, if I need to have as many relationships as I want it to have. Still getting used to my own system here, so bear with me. On a switch state, that's right. Where'd that go? There. Off. And enum gate state, and it'll be, make it open. Two, 4. Alrighty, let's just check that. So 1, 2, on, off, open, lock, locks, open. Okay, that should work. Now let's go into the game and see if that actually works. I've first got to change one thing. No, I don't. I want that one to start locked and I want that one to start open. Okay, let's go into the game. Let me just turn the ambience down and see how that went. Alrighty, let's go in. Just going to turn on the debugging of the triggers quickly so you can see them. And you can see here this one is active and this one is inactive, as it should be, because we said that that one would be locked and this one would be open. So let's go through here. Let's press the switch. So that switch, I'm going to press 2, which should turn that switch off, which should turn this gate off and this gate on. So 2, there we go. This gate is indeed off, and this gate looks like it's on, is it? It is indeed. So there you go, there you can see how that relationship works. It takes 3 parameters to create one relationship. There's no limit to the amount of relationships. And basically every class that I make that has a number of states will be a stateful object. Now let's quickly just switch it back by pressing 1. Let's quickly go back into editor, have a look to see how that's going. Now, before I do that though, I'm just going to explain, this can be even more complex. Because both a switch is a stateful object and a gate is a stateful object, a switch can have a relationship with another switch. So for example, I could have a switch over here that could actually switch that other switch, which would then switch the gates, and you can do all sorts of crazy tricky stuff like that with the system. So, without further ado, let's have a look at it in code. Alright, so if we have a look over here, I'll show you how I've gone and done it. I have made somewhere in here, under my level manager, stateful objects. There are 2 really important things. One is the relationship manager. This relationship manager is required to make the connections between the stateful objects. But let's first look at the stateful objects. This is a stateful object class. Now you can see it inherits from a class called FSM. FSM is my finite state machine. So anything that is a stateful object needs to inherit from the finite state, my standard finite state machine, so it can have different states of being. Now, my SF object it extends that for relationships between states of different stateful objects. It gets a bit tricky explaining this. So you'll see here's a struct up here as well. This struct is SF really, so basically it defines a relationship. In this struct it has a pointer to an SF object, stateful object, the name of that object, the target ID, and the on-state ID. Now these are actually the parameters we set. So this is the name parameter, this is that, this is the on parameter. So on this state, we're basically saying on this state, this SF object, which we use this name to get the actual pointer to the SF object, goes into that state. And this I'm actually going to delete because I don't need it anymore. Now, what happens is these relationships get stored inside the SF object in containers. I'm using STL map containers, and this int is the on state ID. So it'll search through, say for example, SW_on is an enumeration for 1 for a switch. All the relationships that relate to the switch going into number 1 will be stored in the map in number 1. Forget SF release exit and these ones for now. Don't worry about that. Just this one. Now, what happens is, first, because I'm loading everything in with Esenthel's object parameters, each object is going to load in by itself, and it's not going to do nothing. So I need this relationship manager here, first of all, to register the SF objects. So when an SF object creates itself, it actually then registers itself to the relationship manager. It registers a pointer to itself. You can see rman, which is a instance of this, a pointer to the singleton relationship manager. It registers itself to the relationship manager here. Excuse the messy code, I only just really finished it yesterday, Arvo. And then what happens is it can't make the links until everything is loaded, so it has to wait. If you go look at my level manager, here's the game new, this is when the world is loaded. Has to wait till all that's done, and then the relationship manager is called to link relationships. And what that does is it iterates through all the registered stateful objects and tells them to link their relationships. So at this point, they have a bunch of SF release if the object parameters were specified, except the pointer is null. So they have the name, the target ID, on all that stuff, except the pointer. So in link, they're basically going to get that pointer and try and get a valid pointer instead of null. So in link, they go through, it iterates through all the current SF release it has, and then it uses the name to try and get that pointer from the relationship manager. So the relationship manager is a go-to thing. You register to it, and then once all objects are registered, you go through all your relationships, and you go to the register object and say, look, I want this pointer for this object of this name. And it'll go through and it'll give you all that stuff. Now, once it's got the object relationships, it's really simple. That's probably the hardest part, to get all that happening. Once you got that, I simply override my transition to function from my FSM, so my FSM has a transition to function when you transfer from one state to the other, and I simply do the transition, and then if it's linked, I activate all the other states, all my SF release with their relative states, and that happens here. I iterate through all the SF release that have the on state of whatever state I went into, and then I tell them to go to their target state, and that's how it works. It's a really short time to explain this. I really spent a lot of time getting it right. It was really tricky, and it was probably one of the hardest things I've done. I mean, probably not. I probably had a harder time before, but one of the more complex things I've done, and it doesn't look so flash right now visually. I mean, you're just seeing a switch that I've hard-coded and stuff. However, the possibilities are endless. Like, anything that is an object that has states can now affect another object. You know, I can do complex reactions and relationships between objects. So it's quite powerful in that sense, and damn, I'm so glad I'm over it. Usually when I set myself on a task of finishing one thing, it takes me a day to finish one thing. This thing took me like 3 days and so many bugs, so much crashing, and I'm so glad it's done. Anyway, I hope you enjoyed this. I hope you might have learned something. I'm not very good at doing blogs because I just present stuff, but you know what, who cares? So I'll catch you later.